Hey there, my name is Keith and I'm an operations manager here at Gregg Distributors. Today on Gear Up with Greggs, we're going to discuss the basics of grinding and how to keep yourself safe while doing it. Abrasives have been cutting and grinding metal for more than 150 years, starting with simple sandstone and eventually evolving into the many options we have available today. Now, grinding wheels consist of two basic elements, the abrasive and the bond. Abrasives, or grains, should be as hard as possible. While the size of the abrasive varies, generally speaking, the smaller and finer it is, the finer the finished surface of the material you're grinding will be, and vice versa. Rougher grain is typically used for pre-grinding, like cleaning up a messy weld bead, while finer grain is used for finish grinding, such as smoothing the weld before paint is applied. A bond holds the grains together in a wheel and allows open spaces, or pores, to exist between them. The bond, along with the type of abrasive, determines the hardness, strength, and cutting ability of a grinding wheel. While bonds started out as natural minerals, modern bonds are usually composed of synthetic materials such as glass. Organic bonds, such as resin or rubber, are generally suited for harsh grinding conditions that require high levels of stock removal. Vitrified bonds, or glass bond compositions, hold their form extremely well and produce a high ratio of material removal compared to the amount of abrasive wheel used. These types of wheels are commonly used with the medium to fine grain grits needed for precision grinding. Resin is more common and more shock resistant than vitrified bonds, and these wheels are generally operated at higher speeds. They're mostly used with coarse grains in the metalworking and metal fabrication markets. Deciding which abrasive wheel is best for your task comes down to several factors: grade, application, size, type, material, and speed. Grade refers to the strength of the bond in a grinding wheel and is also known as a wheel's hardness. The grade ranges from A, a soft bond, to Z, a hard bond. Grade affects almost all aspects of grinding, including wheel speed, feed rates, and grinding depth. Take a look at these carborundum gold aluminum oxide wheels, for instance. These two discs may look similar, but this one has A24 grade, which is suitable for grinding ferrous metals and various alloy steels, while this one has a grade of ZA30, which means it's ideal for grinding stainless steel and various hard alloys. Next up, knowing your application is critical to choosing the right wheel. Be sure not to mix up cutting and grinding, as they are two very different wheels, both with their own specific applications. For cutting, you need to be sure you have a blade suited for the task. Cutting wheels, like these, are thinner and have a much higher risk of snapping if you try to use them for grinding. They are normally used on angle grinders for quick removal or trimming. On the other hand, a straight grinding wheel is the most common style used for cylindrical and surface grinding operations. There are several other types of grinding and cutting wheels, so be sure to ask your local Greggs representative to make sure you are getting the right tool for the job. The size of the grit in a wheel is just as important as grade or application, even though it may often be overlooked. Every grinding wheel shows a number representing grit size, which is the size of the individual abrasive particles. Lower numbers means that a wheel has a coarse grain. Coarse grains are used when speed, not precision, is key. Higher numbers are fine grit wheels used for detail finishes, small areas of contact, or with hard or brittle metals. A grinding wheels type is a number that refers to the particular shape and use of the wheel. For instance, a Type 1 grinding wheel is a flat, thick wheel mainly used for surface grinding operations, typically on a bench or pedestal grinder. A Type 27 wheel, on the other hand, has a depressed center and is mostly used for blending. Not only do the grinding wheels come in many different shapes and sizes, they also come in many different kinds of materials. The material or grit that a grinding wheel is made of is critical to finding the correct wheel for your application. This grit is typically either aluminum oxide, silicon carbide, ceramic, or a combination of all three. Aluminum oxide is the most common and is used mainly for low to high carbon steels. You'll notice that aluminum oxide wheels come in a variety of colors, which indicates the wheel's grinding characteristics. Gray and brown grit wheels are typically used in bench and production grinding. They are tough and inexpensive, the workhorse of the grinding game. White grit is mainly used on harder steels that need a cooler cutting action to avoid burning the workpiece. Though they run cool, they are soft wheels that break down quickly, so they are mostly used to grind ferrous metal tools like high-speed steel drill bits. Silicon carbide is found in black or green and is typically used as a polishing or finishing grit. This is because the sharp grit found in these grinding wheels dull and create a rubbing action, especially on steel, which produces a better surface finish. Black silicon carbide is used to grind non-ferrous metals like aluminum or brass, as well as plastics, rubber, and stones such as marble or granite. Ceramic is a newer grit, which doesn't dull the same way as other wheels do. Instead, it will break down or fracture into sharp corners rather than dulling and pulling out of the bond. This means that the wheel lasts longer. However, these wheels are also expensive, typically costing 2 or 3 times as much as aluminum oxide wheels. These wheels are not pure ceramic, but actually a mix of aluminum oxide and ceramic, anywhere between 10 and 15%. Zirconia alumina is tough, perfect for high-pressure machining and grinding applications. This combination of zirconium oxide and aluminum oxide is commonly used in general steel fabrication shops, since they are the disc of choice for grinding and finishing steel and stainless steel. They also have good heat resistance and work best between 24 and 120 grit. Now, if you need to remove a lot of material and fast, stock removal speed is something you need to keep in mind. Wheels with coarser grits leave deeper cuts, while wheels with finer grits cut faster in harder materials. Along with the grit, you need to keep in mind the usage speed. Wheels with a vitrified bond are typically used at speeds less than 6,500 RPM, while organic bond wheels can be used between 6,500 and 9,500 RPM. Working at higher speeds usually requires specialized wheels designed for high-speed grinding. In any case, do not exceed the safe operating speed shown on your wheel of choice. So, we know a lot about what these wheels are made of and what they can do, but that's not the most important thing when it comes to grinding wheels. It's about time we talked about proper PPE and how to make sure you don't end up with a nasty injury or worse. When grinding, always be sure to wear safety glasses with a side shield or a full face shield. Keep all shields and guards on your grinder in place. Sure, sometimes it might seem easier to work on a project if they're not there, but they're in place for a reason. Those guards could be the only thing between you and a whole lot of sharp-edged debris if something goes wrong. When installing a wheel, be sure not to over-tighten the nut, since it could crack the wheel. But why does it matter if there's a crack in the wheel? Well, grinding wheels are designed to operate at very high speeds. Because of this, if a wheel shatters while in use, the fragments it creates can travel over 450 kilometers per hour. These fragments essentially become live shrapnel and can result in material damage, serious injury, or even death. So, before you mount a wheel on a grinder, you'll need to do a ring test. A ring test assesses the sound of a wheel when it is tapped gently. A wheel that isn't damaged will emit a clear ringing tone. A wheel that has cracked or has other imperfections will emit a dead sound. Start by suspending the wheel from the hole on a nail or finger. If the wheel is too heavy, rest it on the outer edge on a clean, hard floor. Tap the wheel gently about 45 degrees from either side of the vertical center line and about 2.5 to 5 centimeters from the outside edge. Use the non-metal handle of a screwdriver for lighter wheels or a wood mallet for heavier wheels. Listen carefully and turn the wheel 45 degrees to the left or right before repeating the test. If you are suspicious of a wheel, don't use it. It's better to be safe than sorry. Next, inspect the grinder in wheel position, especially at the tool rest. You should never have more than 1/8 of an inch gap between the tool rest and the grinding wheel. Otherwise, tools or even fingers could get pulled into the gap while the wheel is running. Before you start to work, turn on the grinder and stand back until the wheel reaches its full speed. Once the wheel is going at the appropriate speed, you're ready to work. Over time, grinding wheels can become dull after the grip becomes clogged by a buildup of particles. When this happens, overheating is more common and material removal is slowed considerably. That's why wheel dressing is critical to grinding wheel maintenance. Dressing is a process to clean and restore damaged or clogged grinding wheels to their original state. During the process, material is removed from the wheel, including dull abrasive grains and excess bonding material. Dressing can also be used to get a desired custom shape on a wheel face. Before you start, make sure you are wearing the proper PPE. That means a face shield or adequate safety glasses, along with a dust mask to keep the floating debris out of your lungs. If you are wearing long sleeves, get rid of them. Anything that can run the risk of getting caught in a grinder, like sleeves, gloves, or loose long hair, should be avoided. Roll up your sleeves or switch to a short sleeve shirt and pull back your hair if it is long. Dressing the wheel is simple. Take your tool of choice, whether that's a mechanical dresser or a dressing stick, and once the grinder gets up to speed, hold the tool against the rotating wheel surface and move it back and forth. The whole process shouldn't take more than 5 minutes, and when you're done, you'll be left with a grinding wheel that looks as good as new. Just remember, adjust your tool rest after you've finished dressing the wheel, since the removal of material will likely have changed the amount of space between the tool rest and your grinding wheel. Now, I hope I didn't grind your gears too much with all that information, but if you have any questions, feel free to leave a comment down below or check out our website at greggdistributors.ca. Again, I'm Keith and thank you for taking the time to watch Gear Up with Greggs. I hope you have a great Canadian day.